All right, so 7x, comma, 3. Yes or no?
No,
Why not?
because it doesn't have enough.
Because they both don't have x, right? So they both don't have the variable x. Okay, now, see this 3 right here that doesn't have a variable with it? Let me just remind you about this. So if a term does not contain a variable, if a term does not contain a variable, it is called a constant. So 3 is considered a constant. So if it contains a variable, it's called a variable term. If it contains a variable, it's called a variable term. All right. So if you go back to that example, one term's a variable term, the other one's a constant. There's no way they're like terms because one contains a variable, the other does not. Okay? All right, what about this one? Are these like terms? 4/5 and -2. Are they like terms? In other words, can I put them together? Yes, you did that last semester when you added and subtracted fractions, right? So these are called constants, right? So all constants are like terms. So these are like terms. So all constants are like terms. So those are constants. You're just used to, when dealing with terms, you deal mostly with terms that contain variables, but constants are like terms. They're both constants here. Yes?
What if we have one like number 11 where the variables are backwards? Like say for number 11 they have WZ and the constant is 8, and then they have a fraction, and then it's a ZW for number 11 on page 607.
Okay, so remember, she's talking about this. Are these like terms? Yes or no?
No.
Well, who said no? And why no?
Yeah, they like that.
Yeah, they're like terms. They both contain the variable x, right?
Yeah.
And x being raised to the first power. That was a definition of like terms. What are like terms? Like terms are terms that have the same variables raised to the same power. So do they both contain x's?
Order.
The order doesn't matter. They're both commutative, right? X times y is the same as what? Y times x. That's why we spend a lot of time talking about the commutative property. The order which you multiply does not matter. So they both contain the variable x, and both x's are being raised to the same power. What power are they being raised to? The first. They both contain the variable y, and the y's are being raised to the same power. What power is that being raised to? The first. So those are like terms.
Thank you.
You're welcome. Now, the students who get confused, they always seem to think that like terms of variables have to be in the same order. Is that true? Yeah. They have to be in the same order. The definition of like terms says that they have to have the same variables raised to the same power. Does not matter in what order it's in. Okay? All right. So notice that when we did this, quite a few of you got stuck. Whereas if I had put them in the same order, you would not have gotten stuck. But now you know that the order does not matter. All right. And I think that's it. You should be able to do the rest of these. So when I give you this worksheet, see this table right here? So all you do is indicate whether they're like terms or unlike. So you just check them off, right? Like terms, unlike, like terms, unlike, like terms, unlike, and so on. All right. right, and then here they talked about what's a numerical factor. We talked about that. Go back and let's see. I want to go back to this one where we talked about numerical factor. Oh, we did. Oh no, we did. All right. So you see right here, number 3, we said the numerical factor of x is what? 1. All right. What about if I had number 6? What about if I had negative x? What's the coefficient? Negative 1. Okay, good. Negative 1. All right. And I think you should be able to do all of that now. So that's part A. So that's going to be 8.7 part A. Okay? All right. Now, we talked about like terms and we talked about unlike terms, correct? Now, what you're going to have to do with those is you're going to have to combine them. Combine like terms. So let's talk about combining like terms. It's not that difficult. It's fairly simple. So combining like terms. Okay, so if they're like terms, you can combine them. And it's very simple. Let's start with a simple one that you've done before. 3 plus 2 equal what? 5. They're like terms. Why are those like terms? Because they're called what? Constants. I can combine constants. So I combined them. 2x plus x equal how many x's? 2x. I can combine them. Those are like terms. Notice though, when I combine them, what am I doing to their coefficients? I'm adding them. This coefficient right here is what? 1. This coefficient is 1 plus 1 is 2. 3, suppose you had 5x squared plus 2x squared. So are those like terms? Yes. Can I combine them? Yes. I can combine like terms. And basically all you're doing is adding their coefficients. What's this coefficient here? What's this coefficient here? When I add them up, I get how many x squareds? 7x squareds. Okay, so that's the idea there. So let's look at these. Okay, so this is going to be page 607. And this is number 16. Okay, you have this. You have c minus 7c plus 2c. c minus 7c plus 2c. All right. So how many terms do you see? 3. Are they all alike? Yes. All right. Now remember, you add and subtract from left to right. Remember the order of operations? So let's do this first. So if you don't remember how to deal with signed numbers from a previous course, then use your calculator. And all you're doing is just adding your coefficients. What's this coefficient right here? 1. What's this coefficient? Negative 7. So on your calculator, you say 1 plus a negative 7 equals what? Negative 6. So far we have a negative 6, right? Now you don't have to write in these steps. You can just go from here to the answer, because most of you can. But this is basically what you're doing. You're saying, all right, c and a negative 7c is a negative 6c, correct? But then I got to add that to the other term, which is what? 2c. So what's the answer?
Negative 4c.
Negative 4c. All right. Now again, you could have gone directly to the answer. You could have just written negative 4c. Most of you could do that. Okay? So notice what we did, though. We just added their coefficients. Coefficient here is 1. Coefficient here is negative 7. So you're basically saying in your calculator 1 plus a negative 7 plus what? 2. And in your calculator, what's 1 plus negative 7 plus 2? Negative 4. You see what you do in your calculator? That's all you do. Okay? All right, let's look at 18. All right, 18, you have 6g plus 5 minus 3g minus 7. So 6g plus 5 minus 3g minus 7. All right, how many terms do I have? Are all like terms? No. All right, which are like? The g's, right? And what are those other two called? Constants. Okay, so let's look at the g's first. This coefficient is what? 6. So on your calculator, you're going to say 6 plus, And this coefficient here is what? So on your calculator, you're going to say 6 plus negative 3 equals, and what do you get? 3. You get the number 3, right? So therefore, what's 6g and a negative 3g? 3g. So far I have the term 3g. Okay? Now let's look at your constants. What's this constant right here? 5 plus, what's this constant right here? So on your calculator, you say 5 plus a negative 7, which gives me what? So this becomes 3g what? Minus 2. Okay, good. Minus 2. Okay, so use your calculator. All right, number 24. All right, 24, you have 7.9y minus 0.7 minus y plus 0.2. All right, so how many terms do you have? 4. Which ones can you combine? Okay, so the y's you can combine. The others are called constants. So use your calculator on those. So on your calculator, what's this coefficient right here? 7.9 plus, and then what's this coefficient right here? Negative 1. So on your calculator, what's 7.9 plus a negative 1? 6.9. So what does this become? Okay, good. All right, now, let's look at the constants. What's this constant right here that I'm pointing to? Negative 0.7. So you punch in negative 0.7 plus, and then what's this constant right here? Okay, 0.2. And what does your calculator give you? All right, so negative 0.5. So how do I write the answer? 6.9y minus 0.5. Okay? So any questions on that? Okay. Let's look at 30. All right, 30, you have 8h plus 13h minus 6 plus 7h minus h. How many terms are there? Was that 5? All right, so I have a bunch of h's, right? So let's get the coefficient. What's this coefficient here? So on your calculator, say 8 plus, what's this coefficient? 13 plus, what's this coefficient? 7 plus, and what's this coefficient? Negative 1. And what does that equal?
27.
Say it again?
27.
Say it again?
27.
97? I don't think.
27.
27.
Oh, 27. Okay. 27. All right. It sounded like 90. I'm sorry. All right, 27. Now, y'all agree with that? I didn't work it out. Okay. Because 13 plus 7 is 20, right? 20 plus 8 is 28. Subtract 1 is 27. So it's 27. All right, 27 what though?
27.
H. And then minus 6. That's all you had left was just one constant. So you're done. All right, 36. All right, 36. Zero 0.4y minus 6.7 plus y minus 0.3 minus 2.6y. All right. So do the y's first. So this coefficient is 0.4 plus 1 plus negative 2.6 equal. So 0.4 plus 1 plus a negative 2.6 equal. What does that give you?
Negative 1.2.
Negative 1.3? Is that what you got?
I got a 1.32.
What you'll get?
I got a negative 1.2.
Negative 1.2? Negative 1.2, right? Okay. So it's going to be negative 1.2 what? Y. All right, now the constant. What's a negative 6.7 plus a negative 0.3? Negative 7? So the answer will be negative 1.2y minus 7? Okay. All right, so that's that part. So you should be able to, on the worksheet, part B, let's do this one, right? This example first. All right, suppose you had this. Suppose you had negative 5,6x plus 3x minus 2. Negative 5,6x plus 3x minus 2.
You have to find that LCD.
Okay, you could do that. So what is this? What's up like this? All right. So what do you like terms? These two, right? So this coefficient is what? Negative 5,6 plus this coefficient is what? 3. Okay. Now the problem with using your calculator is that when you say negative 5,6 plus 3, it gives you a decimal, right? Gives you a decimal. So let's see what to do with that decimal. So you calculate, take your calculator out. So which one I'm talking about? All right, so your calculator, you're going to say negative 5,6. So watch this carefully. Negative 5 divided by 6 plus 3. You see how I wrote it? Negative 5 divided by 6 plus 3. Okay? Okay. Then I'm going to press equal. I get this decimal. Now, you don't write your answer as a decimal because there's no decimals in this problem. So don't write your answer as a decimal. Don't say it's 2.16 with a bar. All right? Okay, so that's how watch how you convert this to a fraction. All right. Right above here, see where it says PRB? Right here. And you can't see it very well, but notice the F to D, that means fraction to decimal, decimal to fraction. But it's a different color. It says blue color, so you got to press second to get to it. So you're going to say second, PRB, and as it shows up, F to D, press equal, and now you wrote as a mixed number. So this right here is 2 and what? 1/6. That's what that is. 2 and 1/6. But you got to write your answer back as an improper fraction. So how do you write 2 and 1/6 as an improper fraction? Do you remember? 6 times 2 is 12, and then add 1. So that's 13 over 6. So this becomes right here 13 over 6 what? X minus 2. Okay? So use your calculator with this. So if you had, let's say you had negative 8/9 plus 2. Negative 8/9 plus 2. So in your calculator, you're going to say negative 8 divided by 9, negative 8 divided by 9 plus 2, and then press equal, and you get this decimal, 1.11111. All right, now how to convert that back to a mixed number or a fraction? What do I press? Second, PRB, press equal, and the mixed number, this mixed number is 1 and 1/9. But you got to convert this mixed number back to an improper fraction. This is a mixed number. You got to convert it back to an improper fraction. So you can say 9 times 1, and then add the numerator. Remember that? So 9 times 1 is 9, plus 1 is 10, so that's 10/9. Okay. All right, so use your calculator. Okay, now, remember how to do the long way, though, because you got to know both, because sometimes you're going to be told, depending on a test, now in here you can use your calculator, but in not all situations in college, you're going to be using your calculator. So let's remember how to do this a long way. So from a previous course, how do you add these two fractions without using a calculator? What do you have to find? Least common denominator. So this is a 6 and this is a 1. What's the smallest number that 6 and 1 go into? 6. So the LCD is 6. So that means we'll write two fractions with 6 as the denominator, right? Okay, so now I'm going to write what's called equivalent fractions. Equivalent fractions. Well, these denominators are the same. So that means the numerators have to be what? The same. So negative 5, 6 is the same as itself. Here, though, that's a 1. I want to get a 6. So you're going to say 1 times what is this denominator? 1 times 6 is 6. What I do to the denominator, I do to the numerator. 3 times 6 is 18. Kind of makes sense because 18 divided by 6 is what? 3. Now, since the denominators are the same, I can add the numerators. What's negative 5 plus 18? 13, and it's 13 over what? 6. And that's what we got here. Okay? All right, so do it the long way. You have to find the LCD and the right equivalent fractions. All right. Then, remember we talked about the distributive property? Okay. So let's look at number 46. 46. All right, 46. You have 9 times z plus 7, and then minus 15. 9 times z plus 7 minus 15. Okay, so if that 15 wasn't there, that negative 15 wasn't there, in a previous lesson, how would you get rid of the parentheses? Distribute. So when you distribute, you would say 9 what? Z plus, and then 9 times 7 is 63, right? You agree with that? All right, but I do have an extra term, and what's that extra term? Minus 15. Now what do you think they want us to do with those three terms? Combine them, simplify them. So you're going to simplify by combine. Simplify. Combine. All right, now what terms can you combine? 63 and negative 15. So on your calculator, what's 63 plus the negative 15?
48.
48. So what's the answer? 9z plus 48. All right, so that's 46. Okay, let's see. Let's do 48. Okay, here's 48. All right, 48. All right, you have negative 3 times 2x plus 5 plus 6x. So negative 3 times 2x plus 5 plus 6x. So if you need to, cover up that 6x. So if you cover it up, that part here looks like a previous lesson. So how do you get rid of the parentheses? Distribute. So what's a negative 3 times 2x? What's a negative 3 times a positive 5? Very good. But I also have a what there? A positive 6x, right? Okay, so that's where I'm at. So now what do you think I want to do with this? Combine like terms. Right, so the x is right. So what's this coefficient right here? What's this coefficient? What's negative 6 and 6? We talked about that. They're opposites, right? So you get 0. So the 6x's cancel out. You get 0. So what's the only thing left? Negative 15. So rise negative 15. That's how you do. Let's look at, all right, let's look at this example first. Okay, so I think we did this in a previous lesson, but if we had negative 1 times 2x minus 3, what's that equal to? So you distribute. What's negative 1 times 2x?
Negative
What's negative 1 times a negative 3? Positive 3. A negative times a negative is a positive. Okay? Can I combine anything here? No. All right, then what we did next was we wrote it like this. Suppose we had this idea. How do we get rid of the parentheses? Yeah, so remember, if no number there, it's understood to be a 1. And you would distribute the negative 1, right? So what's the answer? Minus 4. Minus 4. All right? Okay, that's going to take us to this one. And this is going to be number 50. And then we'll stop for today when we do number 50. So here's number 50. You have 2 times 6x minus 1. That's the easy part right here. That's the easy part. Minus, in parentheses, x minus 7. Now don't make this too difficult. The first part's easy. The second part you can do. So it looks like I'm going to be using the distributive property how many times? Twice. The first one's easy. You're distributing a what? A 2. So let's look at that for a moment. What's 2 times 6x? What's 2 times negative 1? All right, so that part was easy. So if I cover this part now, if I cover this up, then that kind of, right here, that kind of looks like this, right? So I'm going to distribute a what? Negative 1. So in your mind, and you don't have to write in that stuff, but in your mind, this is what you have. So this becomes negative x. I'm going to write it right here. And then negative 1 times negative 7 is what? Plus 7. So you'll agree that when you can draw the arrows if you need to. Negative 1 times x is a negative x. Negative 1 times negative 7 is a positive 7. So you have these 4 terms, right? Okay. Combine like terms. I can combine the x's.
11x plus 5.
Say again?
11x plus 5.
Yes. Well, 11x. So 12x and a negative x. So 12 plus a negative 1 is 11, right? So you get 11x, yes. And then a negative 2 and a positive 7 is a what? Positive 5. So 11x plus 5? Okay. Yeah. All right. So we're going to do a few more of these next class period. And I can't give you, well, maybe I could. I think y'all can do this right here, can't y'all? Distribute the 3, distribute the negative 7. You're going to use your calculator with this because that's a decimal. And this. And then we just did this. Yeah, you can do this. So I'm going to give you part B. Yes?
I got one question because I can't remember, like I said, when you're doing like the multiply times square, cube,